but this is exactly the same thing that we just did, so I think this will work. So last time we stopped at the end of the comparator example that we had here, and we walked through the concepts of encapsulation and inheritance and polymorphism, and finally composition and some OOP principles. Did anyone have any questions about anything that we had talked about? Yeah.
Object kind of call other thing. It's really no essential call.
Yeah, so an object needs to be the one to place the request. Don't wait for some other object to communicate with you. If you need the request, you are the one who should initiate and send that request. We'll see that in some design patterns that we cover later in the quarter, where there's quite a bit going on. You have the option to either push the request or wait and pull for the request. So more often than not, you want to send the request when you need it rather than waiting for that update. That way you know you always have the most up-to-date information when and only when you need it. But yeah, that is a great point. All right. So we're going to start back here. So the next thing we're going to talk about is clonable. I'm hoping that this was covered in 211. Does this sound familiar, like something you did? Not really? Excellent. Well, we're gonna talk about it at a basic level here, and it's also going to be part of one of the design patterns that we talk about later in the quarter when we talk about prototype. But clonable is an interface that you can implement that allows you to override a method called clone that tells us how to make a copy of an object. And before we get too much further, I want to make sure that it's very clear the difference between a deep copy and a shallow copy. Do those terms sound familiar to people? If you heard of or know the difference between a deep copy and a shallow copy? Looks like that is something we should go over. So we have an object. This can be whatever we want it to be. And remember that when we have an object, what we really have is a reference to that object. When we name a variable, what gets stored is this, the object gets made, and we have a reference to that object. So we would have something like a name for this object. Let's just call it something very basic for the moment. I'll call it OBJ, just standing for object. When we say OBJ dot something, we're dereferencing the object, and we're starting to talk about the components of this object. We say, take this reference, follow this reference, and start talking about the components of this object. So let's say we want to make a copy of this object. Let's actually give this an object type. So we're going to call this a person object, because I like using person as an example. So now we have something that we're going to call P1. This is going to stand for this particular person object. And this person, maybe has an associated name, which is my first name. It has an age, which is my age. It has some other stuff that's less relevant. So now we have a couple of options or ways that we can make the new person object. What happens if I do something like this? Does anyone know what's actually happening underneath the hood if I write the code person P2 equals P1? And I apologize for the one person that's joining over Zoom. Our back camera is not working, so I can't unfortunately show you the screen. This example will probably just I'll meet with you later and I will discuss this in person. Any ideas what happens here? Yeah.
P2 point to P1.
We're going to make a new reference variable that we're going to call P2. And when we set it equal to P1, we're going to say this is going to point to what this points to. So it refers to the same object. Have I actually cloned this person? Do we have two different person objects? No. But let's say I thought that I did. I could do something like, assuming all of these are public, this is a terrible idea. You do not want your fields of a person object to be public, but I'm just going to write it as if they are public. I could say something like p2.name equals Steve. What does this do?
P2 Steve, given a value is Steve.
So we're going to replace this name with Steve. Note that I also changed P1's name without ever referring to P1. So if I were to do something like print out P1.name, what do you think gets printed to the screen? Steve, is that confusing? Is that weird that you can modify another object that's being referred to by some other? I like to think of this as there's only one me. And depending on who you are, you might refer to me by Chris, you might refer to me by Dr. Kane, but there's only one me. Let's say you hate me so much that you want to walk up to me and deck me in the face. It doesn't matter, Chris or Dr. Kane, both of them are going to feel the pain because there's only one of me. Regardless of how many names I have or could go by, all of them are going to feel the physical pain because there's only one body here for you to deck in the face. So that's a strange way to think about it, but there's only one of these objects. How many objects are there? You know that you're making a new object when you use the keyword new. Since when I made this person P2 object, I did not include this keyword new, no new object was being instantiated. No new object was being created. Questions about this?
You know, you make lots of clones of whatever you wish to.
Oh yeah, absolutely. We call this a shallow copy. You can have an arbitrary number of things. We're not actually creating copies of the actual person. We're just creating new references to the same object. So you can do this an arbitrary number of times. So this is what we call a shallow copy. We call it a shallow copy because we're not actually modifying the details of a new person. We're not making a new person, we're just making a new reference to the same person. So there's still only one object in existence.
So we want to make sure P2 is not a clone.
Yes, so the idea of the clonable or the clone function would be to actually make a new one of these objects and set it equal to the old one. So let's say that we actually wanted to do that. How can I change this code to actually make a new person object instead of just a reference to the same person object? What would we have to do? Don't even give it to me in code form, just in English. How would we make a new object that was a copy of this object? What would we have to do? Yeah, we definitely want P2 to be some new element, but how do we get the aspects of P1 and copy them over to this new object? Is there an easy way to do that? The answer is no, there's not, which is why we write the clone method. So the clone method is going to be what goes through and does all of this logic for you. So in order to do this, you would need to The idea is we want a separate person object with the exact same information. So to do this, we would need to erase on the exact opposite side of the room I started on. You actually have to go through field by field and instantiate each of those fields for P2 to be the same field for P1. So we would say P2.name equals P1.name, P2.age equals P1.age. And it seems like it's an annoying task because it's just repetitively saying everything for P2 is just the same as P1. But the idea is if we could encapsulate all of this in its own method, the idea is inside of that method, we could say something like person P2 equals P1.clone, and that within this clone method would be all of the logic. So the clone would first make a new person, copy over everything from all of the fields within the P1 object and add P2 object, and then return that new person object that we're going to store here in P2. So this clonable interface just says that we need to override the clone method in order to be able to copy the existing object and return a new object with exactly the same values of all of its fields. Does that make sense? All of this work is going to happen in clone, and what clone is going to do is produce this new person and allow us to return it so that P2 now points here toward the new person instead of back toward the old person. Now, if we went and typed the same stuff that we did before, where I say now P2.name, we're going to change this back to Chris. And then print P1's name, what do we expect to be printed? Steve. They're two different objects. This is actually cloning me. And now if you walk up and deck my clone, ha, I feel nothing. So we call this a deep copy. So a deep copy makes a new object, and they're now distinct from each other. A shallow copy, you still only have one object, but you have multiple different references. You can think of it like multiple different names for the same object. But if you try to dereference one of them and actually modify the underlying object, you're modifying it for both associated references, both associated names.
So shallow is copy paste for essentially whatever it is, whereas this deep copy is you're making a template that's different from the original.
I would almost say that a copy paste is more like a deep copy, because when you paste it and then you go edit it, it's not making the change in both places at the same time.
So the shallow is just synchronized.
Yeah.
You punch a clone, both people feel it.
Yeah, because the clone is the same person.
Yeah.
There is no clone.
Maybe deep, you're separate. So if you get one, the other doesn't feel it.
Exactly. I don't know why I like that example so much, but it works. People get the idea of multiple names, same person, two different people. So there's a big difference between a shallow copy and a deep copy. Be very careful about which one you use, because it's a pain to debug. If you think you've made a deep copy and you've actually made a shallow copy, then you make a change and suddenly your entire program's state makes no sense. You're kind of like a ghost, making changes without making changes, and it's spooky. Questions about shallow copy versus deep copy? All right, so there's a whole interface that deals with this for us. You can just implement the clonable interface, and then you can override the clone method, and that will specify all of the logic for making a deep copy of the object. So when you implement the clonable interface, you need to make sure that you implement the clone method, and you need to specify how that object is going to be cloned with a deep copy. One thing to note, this is a very important point. If you don't implement the clone method after you've implemented the clonable interface, then what you get is this strange unknown default behavior that you don't necessarily know what it does. It works slightly differently depending on the kind of object and its underlying representation. So you only want the default behavior if you've researched and know that exactly what you want is that default behavior. If you don't have that default behavior, if you don't know what you're doing, you don't know what you're going to get. And debugging that is a huge pain because something happens and you didn't explicitly tell it what to do. Questions on the clonable interface? It's really just another interface to say implements clonable and then override the clone method to specify how to deep copy an object.
Is this done automatically, or
You have to write the clone. So let's say we made a person object. You would want to say something like this dot, the first field equals, let's actually go through an example. That might be useful. So if we have, we would write something like, let's say this is a person with exactly those two fields again. Should be capital. Assuming that there's nothing in the constructor for a person, we would then say something like, goes with something shorter. So here would be an example of implementing slightly off center. This would be an example of implementing clone. So how do we clone a person? There are only two fields, the name and the age. So you call this is in the middle of the person object. So when we say this dot name or this dot age, eventually somewhere up here, there are the fields for name and age inside of the person class. This is just one of the methods inside of the person class. So we're going to make the new person. This actually instantiates, since we're using this keyword new, we know it's going to be a deep copy. The goal is to be a deep copy. So we're making a new person object. And then we're going to go through and set the name and the age to be the same values as the fields inside of this object. Then we return this person object, and then this allows us somewhere else in client code to be able to say something like, where now this is being called on the P1 object. So we take P1's fields and we clone them, creating a new person. When this returns this new person, that's going to be what gets stored in this P2 object. Questions on this associated logic? So anytime you want, when you're making your own object and you want to be able to deep copy your object, make sure that the object that you're making implements clonable, and then you write a clone method that specifies exactly how to deep copy the object. And then anyone who is using this for their own use outside in some client code can just call clone when they want to deep copy and not have to think about what are all the fields of this object. How do I make a copy of this? The clone method will handle it for them. It becomes a single line instead of a whole process. Other questions? Anyone else need anything from the board before I erase it? I don't know. All right. Next thing we will cover is exceptions. So hopefully people have seen exceptions before. How do we feel about exceptions? We feel good about them, kind of good about them. Don't remember what they are. All right, we'll go over them at a reasonable level. So exceptions are ways that your program is going to break, but it breaks intentionally. Think of it like something happened such that I cannot continue with the algorithm that I'm trying to work towards, and I need to terminate the program and communicate some information back to the user that tells them what went wrong. So for instance, I am using the list interface and I make a new array list. I guess we need a type here. All right, so we make an array list, and one thing that an array list can do is add at a particular index. So I say list.add the number 17 at position 46. Is it going to be possible to insert the number 17 at position 46? No, that's out of bounds, right? So you expect that this throws an index out of bounds exception because the index that we gave it is out of bounds. So an exception is just a way of saying, I can't do this. So there are two times in programs writing / execution where things can go wrong. There are compiler errors, and that happens as we're parsing the Java, and we can figure out this isn't legal Java. And this, if you're working in an IDE, results in a red squiggle while you're writing the program because it's compiling it on the fly while you write it. The issue is this legal Java?
Looks like me, grammar-wise.
Yeah, grammar-wise, it's perfect. There's no way to know at compile time that there's no way to access index 46. So this is going to end up becoming an issue when you run the program. You go to run the program and we go, oh no, this list doesn't have an index 46 that I can put this in. So therefore, I have to terminate the execution because I was not able to do this. So I can't do anything that's after it that might rely on this. Rather than trying to fix this myself, I'm just going to crash, or I'm going to throw an exception. So there are lots of different kinds of exceptions, but the general idea is in your code, you are going to write these exceptions when the user does something that you didn't expect. There's no way to guarantee that your user, think of them as a chimpanzee, a cat, whatever you want to use. Think of something working on the keyboard and using your your program in a way that you didn't intend. There's no way to catch that ahead of time. So you need to identify the logic that is going to help them, one, crash your program, and two, communicate to them what went wrong. To say, why couldn't I continue and parse what you intended? So another definitional way to state it, when you have a contract between a method and its caller that says something like the index needs to be between 0 and the length of the list. If it's not between 0 and the length of the list, I can't do what you just asked me to. So the contract is broken. The ways this can be done, if the preconditions aren't met, the preconditions is just what needs to be true before you go into the method. Some fundamental assumption about your code ends up being false in the current iteration of your code. If either one of those happen, then this is exceptional behavior. If you throw a custom exception like this index out of bounds exception, you don't need to handle it. You don't need to surround it yourself with a try catch. You don't need to figure out what you're going to do. That's on the user, the person who's going to use the tool that you are writing. Let's say, to use the example from data structures, we're programming our own linked list, and someone is going to be using the linked list that you're making. It's not up to you, the programmer, to handle and try to recover from something when they say to an empty list, insert something at index 46. It's on them. When they call the add, they can surround the add with their own try catch and try to catch the array index out of bounds exception and try to do something about it. But it's not on you when you're making the tool. So there are some kinds of exceptions that we want to worry about. There are checked exceptions. So these can be figured out at compile time. So we talked about there being two different times when errors can arise. One when you're writing the code and one when you're running the code. So when you're writing the code, we can access and figure out checked exceptions. So an example of this, so when this happens, it can be caught in a try-catch block. An example of this is a file not found exception. This doesn't necessarily crash the program, but it's something that can be caught. It's something that we can attempt to recover from. Maybe you throw this inside of a loop that says, where is the file located? They tell you where the file is located and you go try to find it and it's not there. You could loop back around and ask them again. It's not there. Did you make a typo? You mean to point me at a different file? An error is what happens outside of the scope of your program. So an example of this is a Stack Overflow error. Has anyone ever seen this before? How have you gotten a Stack Overflow error before? For those of you who have seen it.
The number you have is too big. Oh, it's like a giant number, like 250K something. It's ginormous.
Potentially.
Yeah.
The usual way for this is with recursion. If you have a recursive depth that is too large, then you'll get a Stack Overflow error. For those of you who haven't seen recursion before, don't worry about it. We'll cover it. Well, I guess we'll cover it in data structures. We won't really cover it in here. If you haven't taken data structures yet, don't worry about it. I won't go into too much detail. Maybe I will. We'll figure it out. Another example is an out-of-memory error. There's no way to prepare yourself for an out-of-memory error. You might be writing a program on your laptop that has, we'll call it 64 gigabytes of RAM because you have this beast of a computer. You take your program and it ran fine on your machine and you go put it on a legacy machine that has 2 megabytes of RAM and you try to run it and you get an out-of-memory error. There's nothing wrong with your program. You're just running it on a machine from the 80s. That's the problem. So that's external to your program. It's more the hardware of the machine than it is the code that you wrote. Maybe there's a way for you to write the program where it doesn't take that much memory. Maybe there's not, but it's external to the actual implementation, the logic of the line by line of your program. There's also a runtime error, and this is what happens in a way that we can't recover from. We can't even do a try catch on this. It's your program is going to crash. The question is just, how do you crash? We can't recover from it. An example by this for this is a no pointer exception. Have we seen a no pointer exception before? How does that arise? So an example that would easily do it, let's say we use our person example. So person P1. Is this a legal line in Java? Assuming that I've defined person somewhere. Yes, perfectly legal, right? What has this done? We make this reference object that we're going to call P1, and it points off into the abyss. There's no actual object associated with this reference object. We haven't made a person object that is instantiable. It just points off at nothing. So when we attempt to dereference this, and we would say something like, I'm going to shorthand this instead of writing system.out.println, I'm going to write sout. If I say p1.name, this is where I would expect a null pointer exception. Because if we follow P1 to its associated object and try to grab its name, there's nothing there for me to grab. So it's a null pointer exception. This happens whenever you attempt to dereference, use the dot followed by something else, an object that doesn't exist. Note that there's no way to recover from this. I tell the computer to do this. If there's no such object, can it continue? Can it do whatever is after this? It was not able to access and do this. So if any of this code relies on this or anything of the sort, we're just out of luck. Nothing that we could do. So that's a null pointer exception. It's a runtime because there's everything we typed or we wrote on the board here was legal Java. There's no way for the compiler to know that P1 wasn't instantiated, that a constructor wasn't called on it at some point in some other thread. There's just no way to know. Another example is an array index out of bounds exception. So the three different kinds of exceptions: checked, runtime, and error. Questions on anything from exceptions? You can write your own exceptions. You can, if you're writing your own client code, you can catch exceptions that are catchable. If the type of exception is a checked exception, you can check for it and recover from it. If you're writing the client code that uses somebody else's object or your own object. Yeah.
So when we're like checking for exceptions, like when we write our methods, like the if, say like in your example, like the if name equals null.
Yeah.
It goes a null pointer exception to that.
Yeah.
Would that be different than how your example was, where we just didn't have the person object in general?
It's exactly the same. It's a runtime error. It's not recoverable. So when you see your program crash, that's when you write an exception. If you choose the type of exception that has a string as a parameter, you can write in there a string that gets communicated. So when your program crashes and you see all that red text that says, you got this particular kind of error, that string is what appears in that red text when you get that error. And that communicates, here's exactly what happened that caused the exception. So an intelligent programmer is able to see the type of exception that was thrown, the error message, if the error message is good, and those two pieces of information should help them identify what happened and allow them to run the program again in a way that won't produce a non-recoverable runtime error. Great question. Any others before we move on from exceptions? All right, I'll make this one really brief. Last quarter when I taught this, I thought we were going to be using GitHub a lot more than we ended up using it, which was 0. So I'm just going to very briefly introduce the concept of GitHub, because in later courses, you will absolutely be using a GitHub. And I highly recommend, if you do not already have one, making one. So code versioning and code storage are very important things. If you store your program on your hard drive and then you drop kick your laptop, your program is gone. You can't recover it. And all of that work that you put into it, it's gone. So you need some way to store it on the cloud. If you store it on the cloud, great. But there are better and worse places that have some additional abilities, I guess, for making your life as a programmer easier. And the best one in existence is GitHub. So code versioning is really important. Has anyone written a program, continued writing the program, broken something, and then tried to undo what you did, just step by step, going back to when was the last time that this actually worked? I think we've most likely probably all experienced that at some point in our lives. Wouldn't it be nice if you just had save points throughout, just like in a game, you can just load your last save at the last save point? Or if you had a long history, if you used a new save slot for every time you saved your game, you'd have an entire history of your game's playthrough. This is exactly what happens with GitHub. Every time you commit to GitHub, it's basically creating a save point that allows you to very quickly say, all right, when's the last time that this worked? You can actually look at every history that you've ever made to your code and say, it was right here. Take the current and move it back to here. And then great, you can then continue editing from there very easily. Yes.
I play games with mods, and if I want to find something, I know where to look.
Absolutely.
It's like, oh, wait, why didn't this use before? Oh, here you go.
Exactly. This also allows, and you're going to start seeing this as you get more and more into the upper division courses, you're not going to be the only person who's writing code for the project that you are working on. You're going to be in a group of 4 or 5 or 6 other people, and they're all going to be working on the same files at the same time. Wouldn't it be nice to be able to check out some work, make some changes while someone else also checks it out, make some different changes, and then merge them back together after you've been productive and they've been productive? You end up with the same piece of code without having to send it to each other, sending annoying messages with code or emails with code. And then, do you have the master version or do I have the master version? I don't know. Trying to keep track of all of that. GitHub will keep track of all of that, and you'll have the ability to make changes to code, push the code back to GitHub at the same time that someone else makes the changes and pushes those changes to GitHub. So you can make changes to the same file at the same time, as long as you're not making changes to the same code at the same time. That creates a merge conflict. A lot more features of GitHub will be talked about in software engineering. And as long as you're not taking that over the summer, you'll probably be taking that with me sometime next year. We will look forward to it. In this class, see, now I deleted this from the current slide deck on this laptop. You don't need to worry about it in this class. We're not going to use it. Questions about GitHub or the power of GitHub? I highly recommend starting to store stuff there. Make an account. Whenever you submit a lab, also upload it to GitHub. It's a great way to show a prospective employer, here's all of the work that I did throughout my entire computer science education. That will be very useful if during the hiring process, they want to say, show me an example. You throw up your GitHub, you launch directly into the code, and they can see everything else that you've worked on, and they see that you're organized, you know what GitHub is. That just only is brownie points for you in an interview. JUnit. Who's heard of JUnit testing before? Hopefully most people. If you have not, we're going to be doing an entire unit on JUnit testing following this, but I just want to briefly introduce it to you at the level that you might have seen it before. Who here writes print statements in the middle of your code to make sure that it works? Sometimes there's a better way. Not to say that you're doing it wrong or that you shouldn't be doing it. You definitely need to be doing testing, but printing things out in the middle of your code is annoying because you actually have to run your code in order to be able to determine whether or not it works. You have to comment and uncomment those tests, those print lines in the middle of your working. You don't want to upload code with a bunch of commented out print lines in the middle of it. That's ugly and kind of illegible and not great for eventual readability. The much better way to do it is to write a separate class that contains all of the methods that you write that would do all of that work for the print lines. Embedded in any IDE is the ability to run a whole host of these tests all at the same time. So the tests are separate from the code, and the tests can all be run with a single click of a button. And that will determine yes or no, your program passes all of the tests that you've written for it, or no, there's an issue somewhere and something that should be correct is not correct. So a unit test is just a small piece of code with a particular example. Let's say we wanted to make a new array list. So maybe we're writing an array list class. You could write one that says, make a new list. Can I do that? Great. Another one would say, give it an empty list. Can I add something to the beginning of the list? Another one would say, assuming that I have a list of size 1, add something to the end. Another would say, assuming I have a list of size 1, add something to the beginning. Another one would say, try to remove from an empty list. If you are not capable of removing from an empty list, that's good. That means it's performing as you would expect. If somehow something happens and it's successful when you try to remove from an empty list, that should be a failure case. Something went wrong. You don't want to be able to remove from an empty list. So this kind of behavior that you might want to write in any kind of print statement in between your code, you can factor that out into unit tests. And there's an entire unit testing library associated with Java and any other language that you'd want to code in. So rather than running your code a bunch of different times, trying a bunch of different inputs, you will write your own testing suite, and that suite will become what tests and ensures the functionality of your program. It allows you to then run them all at the same time. And even better, let's say you and all of your cohorts in a group are working on the same code on GitHub all at the same time. You want to commit some code, or let's say everyone's been in a group where they have someone who just doesn't do things right, or at least the way that you want them to. They commit their code and it breaks everything. And then you have to spend time trying to debug and figure out where did they go wrong. One power of GitHub is the ability to what's called continuous integration. It allows you to, when you commit your code to the repository, it will run the entire suite of tests. And if any one of those tests fails, it will not accept the code changes that you've made. This ensures that whatever is on GitHub is always working to the best of the understanding of the tests that you have written. And that is such a nice quality of life. It means that no one can mess up, to the best of your testing knowledge, the code that's online. And it makes it so much easier to work in groups. You also get to see all of the results of all the tests at once. So you can see how many tests failed, how many of those tests succeeded. So it saves a ton of time. We're going to dive into an entire unit on this. You'll learn how to write JUnit tests. You'll learn how to run JUnit tests. So we'll go into this in a lot more detail. And then for labs for the rest of the quarter, you will be writing your own tests along with the code that you submit. What's called test-driven development. You can write all of the tests that you plan to use before you write any code whatsoever. And then you know that you're done writing code when you pass all of your tests, rather than writing the code and then thinking up a bunch of tests and then seeing whether they pass or not. So sometimes it can save you additional time if you write the tests before you write the code. So test-driven development, we'll explore that idea later. Some examples. I think that basically sums up some ideas or some basic examples of what you could do with unit tests. And rather than dive into the next thing, I think it makes sense to stop here. Anyone have any questions or things I can answer while people pack up? All right, I will see you all tomorrow.
Yeah, we got to decide that one.